Hello student, I am Dr. S.L. Munde, Assistant Professor, Department of Mathematics, Sri RLT College of Science, Akola. Today we will see index of a closed curve, definition, some basic concept. Then we will see the proposition, or we can say the theorem on an index of a closed curve. First we will see the definition of the index of a closed curve. So the index of a closed curve is also called as a winding number. Okay. So what is the definition of the index of a closed curve? Let gamma AB tends to C be a closed rectifiable curve and the point A belongs to curve gamma, then the 1 upon 2 upon pi integral over gamma dz upon z minus A is called as the index of a closed curve gamma about the point A. So this is the index of a closed curve about the point A, and it is also called as a winding number of a curve gamma around the point A. Okay, and it is denoted by eta of gamma A, and it is written as eta of gamma A equal to 1 upon 2 pi integral over gamma dz upon z minus A, or this can be written as integral over gamma dz upon z minus A equal to 2 pi I e2 of gamma comma A. So this is the definition of the winding number, or we can say the index of a closed curve at a point A. Now we will see there are some nodes of related to index number. What is the node number 1? The index of a closed curve is always either positive or negative. Okay. Second, if the closed curve gamma is in anticlockwise direction, then the index of a closed curve is positive. If the closed curve gamma is in anticlockwise direction, then the index of a closed curve is positive. And if the closed curve gamma is in clockwise direction, then the index of a closed curve is a negative. And suppose if the direction is not given, okay, then always consider it is the anticlockwise direction. Okay, suppose that if there is not given in direction, then we have to consider the given direction is in the form of anticlockwise direction. Third note is if the point A, where is any point in a curve gamma outside of the closed curve gamma, then the index of a closed curve is 0. Okay, suppose that the given point A which lies outside of the curve gamma, then the index of a closed curve for that point A will be the 0. Our winding number is 0. For example, this is a point A which is lies inside the curve gamma. Okay, so therefore the index of a closed curve is 1. Okay, and it is written as index of a closed curve gamma at a point A equal to 1. And for a point B, this is the B point. Okay, and the direction is given in anticlockwise direction. Okay, the point B which is outside of this closed curve gamma, and therefore we can say the index of a closed curve gamma at a point B is 0. Second example, so this is the another curve is any point in a curve gamma, and here direction is given in clockwise direction, that means negative. If the direction is anti-clockwise direction, then index of closed curve is positive. If the direction is given in the clockwise direction, then the index of closed curve is negative. Okay, so here is any point which is lies inside the curve gamma. Then the index of a closed curve gamma at a point A is given as -1. Why -1? Because the direction is given in clockwise direction. Therefore, this is the minus. Okay. Third example, let us suppose that A, B, and C, these are the points. Okay. So where A and B points is lies inside the curve gamma, and direction is given is anti-clockwise direction. Therefore, the index of a closed curve for point A is given as, so this is the first winding, okay, and this is the second winding. So therefore we can say that the index of a closed curve of a gamma at point A is 2, because this number is wind by 2 times. Okay. Then index of a closed curve at a gamma at a point B is 1, because this is a B point and only winding by only one time. Okay. So therefore winding number is 1. And index of a closed curve at a point C is 0, because this C point is lies outside of the curve. Therefore the index of a closed curve is 0. Okay. Now we will see the one theorem, or we can say that the preposition of a winding number or a index of a closed curve. What is the preposition statement? If gamma 01 tends to C is a closed rectifiable curve. So this is the curve gamma, and limit are 0 to 1. Okay. Starting point 0 and ending point is 1. It is a closed curve, rectifiable closed curve. And the point A which is not belong to curve gamma. Okay. Then 1 upon 2 pi I integral over gamma dz upon z minus a is an integer. We will see the proof of this theorem. So what is given? So we have given curve gamma a 0 to 1 tends to c is a rectifiable curve, and the point A which is not belongs to curve gamma. To prove this theorem, let us we define a function g 0 to 1 tends to c, and it is defined as g of t equal to integral 0 to t gamma dash of s upon gamma of s minus a ds. Let us we consider equation number 1. Okay. For the value of t equal to 0, so this can be become 0. Okay, because upper limit and lower limit both will become same. Okay, if the upper limit and lower limit is same, then the value of that integral must be the 0, will be the 0. Okay, so therefore at a point t equal to 0, so this integral gives the value that is 0. Now for t equal to 1, the above integral can be written as 0 to 1 gamma dash of s minus 1 ds. Okay, now we will put gamma of s equal to z, gamma of s equal to z. So differentiate with respect to z, gamma dash of s ds equal to dz. Okay, so we will put this in our equation. In this equation we get g of 1 equal to integral or curve gamma dz upon gamma dash of s ds means dz upon z minus a. So this is the curve gamma along to the z, the point z along to the curve gamma. Okay, so multiplying on both sides 1 upon 2 pi I, we get 1 upon 2 pi into g of 1 equal to 1 upon 2 pi integral curve gamma dz upon z minus a, equation number 2. Okay, now to prove this theorem, we have to show that 1 upon 2 pi I g of 1 is an integer. That means we have to show that 1 upon 2 pi integral curve gamma dz z minus a is an integer. Okay, so if you show this LHS is an integer, then we can see that from this equation number 2, RHS is also an integer. So to prove this theorem, let us we consider the term derivative of dt of dt e raised to power minus g of t equal to into gamma of t minus a. So what is the derivative of this term? So derivative of first function into derivative of second function, that is e raised to power minus g of t and into gamma dash of t, differentiation with respect to t, plus second function into derivative of first function, that is gamma of t minus 1 e raised to power minus g of t into derivative of this upper term, that is minus g dash of t. Okay. Now for this term g dash of t, we will use equation number 1. What is the equation number 1? Equation number 1 is g of t. If you differentiate with respect to t, so this integration will get cancelled. So gamma dash of s upon gamma of s minus a we can put for the t. So using equation number 1 for the t, we put here g dash of t. So left hand side as it is e raised to power minus g of t into gamma dash of t minus gamma of t minus a e raised to power minus g of t into put the value of g dash of t, that is gamma dash of t divided by gamma of t minus a. So this term and this term will get cancelled. So only remaining term will be dt of dt e raised to power minus g of t gamma of t minus a equal to e raised to power g of t gamma dash of t and into this. Okay, so this both will get cancelled, that means will get 0. So taking the integration on both sides, we will get constant e raised to power minus g of t gamma of t minus a equal to constant. So hence we can say that e raised to power minus g of t gamma of t minus a is a constant function in interval 0 to 1. Okay, so which implies for the t equal to 0, we get e raised to power minus g of 0 gamma of 0 minus a equal to e raised to power minus g of 1 gamma of 1 minus 1. Okay, equation number 3. But gamma is a closed curve defined on interval 0 to 1. Okay, so therefore gamma of 0 equal to gamma of 1. Then above equation 1 becomes, the equation number 3 becomes e raised to power minus g of 0 gamma of 1 minus a raised to power minus g of 1 gamma of 1 minus 1. So this term will get cancelled on both sides. So what is the remaining term? So remaining term is, if you transfer this term to LHS and if you transfer this term to RHS. So this can be written as e raised to power g of 1 equal to e raised to power g of 0 into e raised to power 2 pi I k. So this is the 1. This is the value of this term is 1. So we can write in this term in this way. Okay, for the any integer k. Okay, so taking log on both sides, we get g of 1 equal to g of 0 plus 2 pi I k using product formula. Okay, but we know that g of 0 is 0 from the equation number. Okay, g of 0 equal to 0 from this equation number, from equation number 1, or from this g of 0 equal to 0. So put g of 0 is 0, 2 pi I k. Okay, so here k is any integer, so therefore 1 upon 2 pi I, we can transfer this term to here, 1 upon 2 pi into g of 1 equal to k, where k is an integer. So 1 upon 2 pi integral over gamma dz, put the value of g of 1, integral over gamma dz upon z minus equal to k, where k is an integer. Okay, so therefore from equation number 2, we can say that 1 upon 2 pi integral or gamma dz z minus is an integer. Okay, so this is the preposition on index of a closed curve or a winding number. In next lecture we will see some problems on a index of a closed curve or a winding number.